Alright, part 7, the first part of the second series about the Korg Volca Modular. This second series may well be nicknamed Volca Modular and Friends. And today's friend is the Moog Werkstatt-01. I'm going to assemble this great little Moog synth. I'm going to calibrate the CV, and I'm going to integrate the machine in my hybrid do-it-yourself Eurorack system, right next to the Korg Volca Modular. And then these two guys are going to jam together and as parts of the whole system. Well, let's get going. After registering the Werkstatt at Korg's website, I've got an email containing not only the material which everyone can download from their website, but also nice instructions how to undertake some interesting hardware hacks. Well, maybe later. Assembling first. Let me take the assembling instructions which came with the device and try to follow them. Well, everything prepared. The board. Yes. Front panel. The case. Yes, the CV output jacks. Oh, that's nice. Because, let me show this. Okay. Because I was skeptical about this feet here, because I don't want them, because of the special way I want to sorry because of the special way I want to attach mechanically the Werkstatt to over there to my hybrid do-it-yourself modular synth. You remember from the last video with the Korg Volca Modular, and these feet would disturb, and I thought we need this rubber bumper to protect the mainboard, but it's not the case. But as you see, these are the holes where I have to screw this mainboard in, and they are longer, so there's no need for these feet. That's good. That's really a nice thing. Patch cables, quite short ones, but okay. Power supply, different adapters. 12 volt. Yes, 12 volt. 12 volt, that's nice. You can imagine why. I'm thinking of common ground problems. Common ground, Volca Modular, and the rest of my super hybrid modular synth over there. And with 12 volt I can use the power from the Eurorack power supply inside there. Part list. Okay, at first the feet. I won't use the feet, I told you. And then put it inside here. Yeah, okay. I have the wrong glasses on here, but okay. By the way, what I have learned already is that the ground of the circuit, the common ground of these modules here, not the common ground with the rest of my machine over there, is over the case, over the metal case. And so the screws ensure that everything is nicely grounded. Let's see here. Yeah, you can see from the screw, from the ground, from the case, through the screw to the circuit here. I'll talk about the circuit later a little bit. So 1, 2, 3, 4, 5 screws. Okay, and then what should I do next? Yeah, I should black the nylon hex nut. Place the 13 button caps on the keyboard buttons. One I have already here. So, tiny. The next step, as you see here, the next step is attaching this front panel. I won't do this as the next step because maybe that I have to calibrate the CV so that the Werkstatt can work properly together with my system over there. And to do so, I have to use one of these trim potentiometers. The thing is, I always think, hey, Rolf, have you explained enough what I think is so revolutionary with my strategy of building a large modular synth system in this way. Once again, let me say it. Let me say it again. This here, of course, it's, you see, one machine, but it's more than just one machine. It's a couple of modules which I can use individually for a wonderful price, quite wonderful price. And I'm not that sure whether I'm going to use, oh, I have to, what's this? Ah, okay. Whether I'll use this, the CV adapter. The advantage is not only that I could use normal patch cables, but also it's larger. Yeah, you can see the labels are larger than they are here. Quite small labels here. But on the other hand, this machine is going to be placed right next to on the left side, next to the Korg Volca Modular, and so I would lose space here, yeah, because I need the space for patching these cables in. At least that much. There must be at least that much space between the over there. Yeah, you see. I think I showed you already. Between the Korg and this Moog. And what's more, I'm using these kind of cables, already with the Korg Modular, Volca Modular. I told you, I showed you and told you and explained, and also explained the thing with common ground in the last video, perhaps even in video number 5. The next step is finding out which of these trimmers. I think this one, there's written VCO, yeah, so it should be this one, but I'll look it up. The next step is calibrating, if necessary. I'll check it at first. All right. Before I show the process of calibrating, I'd like to say some words to avoid a misconception. Calibrating doesn't mean tuning. Calibrating means to ensure that the Moog Werkstatt's VCO follows the 1 volt per octave characteristic. I increase the CV, the control voltage, that arrives at the oscillator by 1 volt, and I get the same note but 1 octave higher, exact 1 octave higher. That's what I want to ensure by calibrating the machine. 1 octave up is double the frequency. Each volt more has to result in a doubling of the frequency, and the other way around. 1 volt less CV has to result in half the actual frequency, the same note, just 1 octave down. The calibration is done using the trimmer potentiometer in the VCO section under the hood of the machine. The tuning is done by using the VCO frequency knob on the front panel. All right. The oscillator, the VCO, is oscillating at any time the machine is powered up. Always, all the time, without taking a break. With the tuning knob on the front panel, I determine at which frequency the VCO is running. A certain frequency means a certain amount of control voltage level. to be precise, it's about levels. And the keyboard or any other external CV source increases this frequency by adding CV, adding control voltage to the VCO. Well, technically it isn't that simple, but to understand the process of calibrating, what I'm going to do now, for that my explanations here shall be sufficient. All right, at first some words about the setup. The CV comes from the control voltage for the frequency of the oscillator comes from the Arturia key step here. So I'm sure that the difference between two notes being apart 1 octave is from each other 1 octave is indeed 1 volt. So 1 volt per octave characteristic is what this machine delivers. The reference sound comes from the Neutron. I know that this Neutron is exact as well because I have calibrated it very patiently. So it reacts, it follows the 1 volt per octave characteristic. And here is the Werkstatt which I have to calibrate. From the key step there, the CV changing the frequency goes out to a buffered multiple. From the buffered multiple, one cable goes to the Neutron for delivering the reference sound, and one goes into the Volca, into the Moog Werkstatt. All right, and then both audio outs go to the mixer so that I can hear both sounds. First thing to do is I need only the sound from the Werkstatt. So let me put this down. Oh, that's the wrong one. And I don't hear anything. I don't know why. Ah, yes, here. So now I'm hearing this, or we are hearing the sound from the Werkstatt. And see over here, we see the spectrum. I'm recording the sound as well. So what I want to do is I want to find out which key delivers exact 0 volts, doesn't add or subtract anything to the frequency of the oscillator, the frequency the oscillator is running at the moment. And to find out I have to find the key on the keyboard, but I reduce the sound again, otherwise I don't hear myself. So, yes, to find the right key, I have to find the key which this trimmer potentiometer, the trimmer of the voltage controlled oscillator, it doesn't have any influence. So I take this C, turn the trimmer. Oh yes, it has influence. So 1 octave down, once again. Still influence. 1 octave down. Still 1 octave down. And 1 octave down. And here we are. I can turn it extremely. Nothing matters. So this is the 0 volt key. Now I turn up the volume. I have the bias. I turn up the volume of my reference sound source, the Neutron. Not quite near. And here we see, and we hear that it's not in tune. So I tune it at first. I tune it at first. Change the trimmer a bit. I think that's okay. Now I go one octave up. So let me at first try. I see I'm not in tune anymore, and now I calibrate, because this difference of 1 voltage changes the frequency of the neutron by 1 octave, but not at all by 1 octave the frequency of the Werkstatt. So I have to calibrate. Good. 1 octave up. And once again we are out of tune, so I calibrate. Okay, and 1 octave up. I'm happy with that. And 1 octave up. Not exactly. I will do some more tuning work later, but I don't want to bore you in this video. So you see the principle. You have seen this principle. One thing to explain: why did I use these CV output adapters? CV adapters. Well, the question, the reason is a good grounding. I'll talk about grounding later in this video, but I'll reduce the sound and I'll stop the recording here on the computer. All right, as you see, I'm using OBS Studio to record. I love this freeware software. Okay, once again, yeah, I'll talk about the grounding later, grounding problems later in detail. But for now, the thing is, I get CV and the gate out of this Arturia and using these jacks, and I could of course use adapter cables like this one and then take care about common grounding in a different way, but it would be too complicated. Right now we have common grounding between common and shared ground level between the Neutron, the Arturia, and the Korg Werkstatt. And by some means even with the rest of the system, but not perfectly. I'll talk about this later. Yeah, so far the calibrating, and now I can remove this part and continue and finish the assembling. What's more or less only left is just putting on the front panel. All right, let's do so. So let me finish the assembling process. I've removed the CV adapter again, put on the front panel. Yeah, the holes fit. Now I need these black screws. Korg tail. It needs a little bit of extra power, and it does indeed at the beginning. So I take the larger screwdriver. Yeah, it works better. Yeah. All right. This one. And now I install the CV adapter, even if I'm possibly not going to use it later, in this case over there, because I want to demonstrate some things with the Moog Werkstatt at first, before it comes to common working, together working, cooperating with the Korg Volca Modular. So once again, on behalf of good grounding, I screw it. Just a moment. Yeah, come on. All right, that's quite easy because it was screwed already. And the next one. The last one. And so we are ready for demonstrations. Okay, but first I wanted to show you this beautiful box where it came, where this machine came in with this nice rafts. Can you see it? Can you see it? I hope you can see it. Let's look at this. And what is written here? The quotation of Dr. Robert Moog: everything has some consciousness, and we tap into that. It is about energy at its most basic level. I'm quite sure that's a meaningful saying. Yeah, oh, no, it is indeed. All right, so let's go over there to this machine, and at first work only with the Werkstatt, some circuits, not some circuits, but some signal flow examples, and then cooperating the Korg Volca Modular and the Moog Werkstatt. And don't worry, I will talk about the main board and the circuit on the main board later in this video again. All right. Well, a short overview over the machine, only a short overview. Anyway, it's not an in-depth tutorial about the Werkstatt. First of all, when you attach or when you close the case, when you attach the front panel, please take care not to push down one of these keyboard buttons here permanently. I did so, and it's hardly to be seen, or it's really not to be seen. You can't see whether a button is pushed down by the cover, by the front panel here. And I wondered why the Werkstatt didn't want to stop giving sound. Well, there is a regular way to make the Werkstatt sound permanently without having to touch a key, and this is switching the VCA mode from envelope generator to on. And then let me take my headphones so that I hear it as well. And then you get a permanent sound. Okay, let me put it, switch it back to envelope. The VCO offers two waveforms: pulse, what is at the moment, and saw. With pulse wave, I can adjust the pulse, the duty cycle, and but only, and take care, only when the frequency, the FCO modulation target is set to frequency and not to pulse width modulation, because otherwise the pulse width reacts only to the LFO. But let me put it back to frequency. I'll talk later about the VCO modulation a bit. So with the pulse width knob, I can change the pulse width. Here we are at the regular square wave duty cycle. All right, let me put it back. Below the VCO, there is the VCO modulation section, and we can choose between two modulation sources, envelope later, and LFO. Let me leave it at LFO, and we can choose between two modulation targets, pulse width and frequency. Let me switch it to pulse width, switch it to LFO, and here I set the amount. I switch the VCA mode to on. envelope. The envelope generator as a source for the pulse width modulation. Let me set a little bit more of decay. And the amount, I need more amount. And the other way, attack. Okay. Well, and of course I can make the LFO modulate the frequency. Sorry, envelope, the LFO. And of course I can even choose the envelope generator here to modulate the frequency of the VCO. And let me switch it back to saw wave to get a little bit more on partials in the spectrum. The rate of the LFO goes up to audio rate, so that it's suitable even for simple frequency modulation effects. The waveform is triangle or square. All right, let me come to the most moogiest, or the moogiest part of the engine, the filter. It's a low-pass filter, and with a typical Moog sound. I have saw wave, yes, let me demonstrate this. No modulation. Wonderful. I could do it the whole day. No, not really. Besides the cutoff, I can also, of course, adjust the resonance. Even the filter is, it's possible to modulate even the filter. And in the VCF, the filter modulation section, we have, same as with the VCO, target sources, envelope, or LFO. We can adjust the amount, and with the envelope as modulation source, I can choose between positive and negative. Negative means the attack is kind of decay, and the other way around. Let's come to the envelope. The envelope has two knobs, attack and decay, and the decay knob sometimes works as a release. Let me explain this. With sustain on, I have a sustain phase, meaning as long as I touch a key, we will hear sound. And with high decay, increased decay, and when I leave the key alone, the decay determines how long the sound is still audible, so it's typical release function. But with sustain off, the decay knob determines how long the note is audible at all, because it doesn't matter whether I still have my finger on the keyboard or on a key or not. After the decay time, the sound is gone. Oh, sorry. A little bit longer. The sound goes down, quite long, and vanishes, even if I leave my finger on this key. All right, and of course we have attack. Sorry. Okay, a little bit of patching, only a little bit now, here at this stage of the video. Later on a lot more, but here in this case, together with the Korg Volca Modular. I have I use these the CV adapters again, and I have decided, I have made up my mind to use them always, to leave them on. There are two reasons. The first reason is it's just easier to handle. It's better to read, and it's easier to handle with these things. And the other way is for reasons of good grounding. Yeah, if I will talk about electrical ground in very short time. Be patient, but it's better for it's easier to ensure good grounding. So let me, for example, use, let's say, the LFO out to modulate the VCA. Nice amplitude modulation. Another way, what I could do is I could use the VCO out and patch it into the VCO exponential in, feedback, frequency resonance. Yeah, frequency modulation feedback. The VCO is modulating itself. And another thing, last thing perhaps, using, change to keyboard again, also to envelope generator. The last thing, I could use the envelope CV out to modulate the LFO's frequency. And now the LFO's frequency is dependent on what I have adjusted here with the tech and decay. Let's use more decay. LFO in, yes, and envelope generator out, yes, right. Also, okay, the LFO should have an effect, otherwise we cannot hear it. Let me use the frequency of the VCO as a modulation target. Yes. And you hear at the beginning it's high, and then according to decay it goes down. Or the other way around. All right, let it be enough now. So only one step left before we can, before I can show you how I integrated this machine into my hybrid do-it-yourself modular synthesizer rack. And the last thing to talk about and to find out is electrical ground at last, and voltages, CD voltages, and maximum possible voltages. Electrical ground. I know that a lot of you like some basic explanations, and so let me shortly explain the basics of electrical ground. When we talk about voltage and volt, we used to be quite inaccurate, because the term always means voltage between 2 points, between 2 electrical potentials. When we say, read or write things like, the signal strength is plus 5 volt, then we leave out the second part of the information, which is plus 5 volts compared to, yes, compared to what? Well, compared to electrical ground. In other words, the exact statement should be, the signal strength, the electrical potential at that patch point is by 5 units higher than the electrical potential of electrical ground, which we suppose to have an electrical potential of 0, so that the voltage between these 2 points results in 5 volt. Wow, that's a sentence. But what and where is this electrical ground physically? Where can I see it? Where can I touch it, buy it, or destroy it? What is it made from? Well, electrical ground is a theoretically infinite reservoir of freely movable positive and negative electric charges, so large in numbers that it doesn't have any consequence when I take electrons away from it or put electrons into it. And that's the reason why the electrical potential of ground is always 0. And what is it made from? Well, for example, the Earth is such an electrical ground, or a larger piece of metal. There are even ways to generate ground electronically. Now you can imagine that there isn't such a thing as the ideal, the perfect, the theoretical ground whose electric potential is always and unchangeable, exactly zero. Technically, it isn't even necessary to be always 100% unchangeable and 100% exactly zero without even the smallest fluctuation. But there is something that is really necessary, and that is the fact that all devices which shall work together and which exchange electrical current, electrical signals, share the same electrical ground and undergo the same tiny, tiny changes of the electrical ground at the same time. It's like two men standing on two ladders on two different floors. Terms like high and low don't make sense when they don't share the same level zero. And as long as they don't, they cannot sensibly talk to each other about height. My synthesizers over there and my printer over there, they get their power from different electrical networks. My flat has a couple of different networks, fortunately. If they were to communicate, their communication would lead to malfunctions. But they don't communicate. Or do they at night when I'm sleeping? Well, serious. But the modules of my hybrid modular synth, they do communicate as well as the modules in my Moog Werkstatt do. The common and shared ground of the modules in the Moog Werkstatt is simply the metal case. The metal case, like I mentioned it before. All ground connections in the circuits are connections to the metal case. The common and shared ground in my hybrid modular synth is delivered by the Eurorack power supply. Those of you who have seen video 6 of this series know more details about it. If I were to integrate the Werkstatt in a setup with a couple of other synths, I could, and would, simply attach a piece of metal wire to one of the screws and connect this wire to electrical ground, perhaps also the metal case of the other synths. It would even be okay to connect one of the jacks of the CV expander to a corresponding jack of the other synth. Some videos on YouTube show that, and that's a valid way. It's a valid way because with the CV adapter I don't even have to do this thing with the metal wire because the adapter is screwed to the case and the jacks deliver signal and ground. But I'm going to integrate the Moog Werkstatt in my modular system, so the best way to ensure common and shared electrical ground and to have a comfortable way of powering up is using the Eurorack power supply to power up the Werkstatt and to deliver ground. Well, let me do so. I found an old wall mount power supply. I don't even remember what it was used for. Oh well, it's old, but the plug fits perfectly in the Moog's power jack. I cut it off. And then, with a bit of soldering, only a little bit, I get a nice little Eurorack to Werkstatt power adapter. One cable delivers plus 12 volt, the other, which leads to the plug's sleeve, is connected to ground. Well, let's try it out then. Yeah, and it works. Great. So now I can place the Werkstatt over here. All right. Even if the power supply of the Moog Werkstatt delivers 12 volt, you should not go remarkably above 5 volt with the signals you put in. A short look at the circuits, you can download them from Moog's website, shows that most of the ICs are powered by only a reduced voltage of 5 volt. Some quick further investigations concerning the used ICs reveal that most of these integrated components could have been powered up by up to 20 volt, so they probably would endure higher signal levels than only 5 volt. but signal levels above 5 volt would have no other effect than those of 5 volt only, because no output of any electronic device can be higher than its supply voltage. And what's more, there's even one integrated circuit device on the Werkstatt mainboard which would get damaged by remarkably higher voltages than 5 volt. Than 5.5 volt, maximum 6 volt. But I'll have no problems with that. As we have seen in video number 6 of this series, the Korg Volca Modular has only one output which is able to deliver more than 5.25 volt, and that's the utility unit's A plus B times C output. I'll keep that in mind. And the Neutron delivers more than 5 volt only at the audio outputs of the two oscillators, and at the noise output. I'll keep that in mind as well. All four mentioned outputs are going to be sent through attenuators before I patch them into the Moog Werkstatt. And in case of some later doubts, there is my integrated oscilloscope after all. I'll take a little bit of a closer look at the electronics of the main board at the end of this video. But now it's time to integrate the Werkstatt also mechanically in my hybrid modular synth rack, like I did with the Volca Modular in video 6, and start patching at last. Let's go for it. So, let me find out if the signal flow between these components work. At first, only between the Werkstatt Moog and the Volca Modular. So, I take the LFO out from the Werkstatt. Yeah, but I need to use my headphones. So, all right, and I want to modulate. Well, let's make it simple. The pitch. Yeah. Yeah, that works. Now I want to use the keyboard, the envelope out. It works. Now the other way around. I patch an LFO here with the Volca Modular. Yeah, okay. And use the LFO to, well, let's say to modulate the VCA of the Werkstatt. I switch the Werkstatt to permanently on. Yeah. Yeah. Or let's modulate the filter, VCF. Yeah, okay. Let's switch it off. Now the question is whether the signal flow, the CV, between the Moog and the Neutron works perfectly. So I take once again the LFO out of the Werkstatt. At first I open the bias with the Neutron. Okay. And, well, let me modulate the frequency. Yeah, and it works. And now the other way around. Let me once again use, let me once again use the filter. I want to modulate the Werkstatt's filter by the LFO of the Neutron. Something. minute ago it worked. Perhaps it's the cable, so let me try another cable. So LFO out to filter in. No, it doesn't work. Why? Oh, of course. I'm so stupid. I have to switch it on here. Yeah, and here we are. Yeah, otherwise I would have to touch a key on the keyboard, of course. Yeah, as you may see, when you look at the lights here, it's again very early in the morning. So the signal flow works, and now it's time to go a step further and start patching real and more interesting patches. There's a big minus of the Moog Werkstatt to talk about first. You might have been looking forward to patching the, well, West Coast oscillator source of the Volca Modular into the, well, East Coast Moog ladder filter and play with different cutoff frequencies and different filter resonances. I was looking forward to doing so too. But it's no fun, nor does it make a lot of sense, because it's not possible to block the sound of the Werkstatt's VCO from its filter. You always get both the filtered Moog sound as well as the filtered external audio input. And what's more, the external sound will be very, and I mean really very quiet compared to the Moog's sound. To improve this, to disconnect the permanent connection when something is plugged in the external audio jack, or even better, to be able to blend the internal sound from the Moog VCO in and out and mix it together with the external sound. That's one of a couple of important and useful hardware hacks I'm going to show you in the next video. And don't be afraid, it's not going to be that complicated. But for now, let's use what is possible and mess around with some patches in this video today. The Werkstatt is running at pulse wave. Pulse width modulation is turned on, slight amount, modulated by the LFO. And let me turn the VCA on, permanently on. All right. So let me start with something simple. The key step here, the gate out is to the gate in of gate in 1 from the Neutron, and the frequency of the Neutron's oscillator 2, oscillator 1 I'm not using in this patch, is patched to, of course, the pitch out here of the Arturia key step. So let me fade it in and start the sequence. Here we are. Yeah. All right. Stop. Simple so far. Now I patch the VCF out into the space in of the Volca Modular. And fade the Volca Modular in. But I don't want the sound coming out of the Volca Modular's space unit. I want it a little bit more complex, a little bit. I take the space out and put it into the delay in of the Neutron, I lose. Let me make things a little bit quieter. I lose the sequence, so because by patching in something in the delay in, I interrupt the signal flow, the audio signal flow from the oscillator to the output. But I don't want the sequence right now. I'm coming back to sequences a little bit later. So let me play around with different delays and different space amounts and different frequencies of the AVCF cutoff frequencies and different resonances. Here's the delay. I'm just playing around with the delay time. Different amounts of space. And changing the delay time. Resonance and cutoff. All right, this is the first very simple patching in this whole system. Let's go to the next one. But before I go to another patch, let me just change the target for the sequencer, and let me sequence the Moog. So I take the gate out from the Arturia keyboard, the gate out to gate in, and frequency modulation, the pitch out to VCO exponential in, and start the sequencer and fade in the Neutron, because the sound from the Moog is going into the Volca Modular, the space unit, and from there to the Moog, to the Neutron, and to the delay, and then to the mixer. So, without space, and now fade in space, and once again. Now I change the frequency. Reduce the space. And the cutoff. And play around with the delay a little bit. And increase the frequency again. and the space. Okay, but now at last to the next patch. In this patch I want to make use of two different LFOs running at the same time. The LFO here in the Werkstatt and the LFO, the patch LFO in the Volca Modular. So let me at first patch the Volca Modular LFO. So, all right. And I patch the LFOs out here from the Volca Modular into sum 1A, the summing module of the Neutron, and then I take the LFO out from the Werkstatt. And here is it, yes, and patch it into sum 1B in, and from there I take the output of the sum of both LFOs at first and patch. I'm going to patch it into the frequency modulation of oscillator 2, but at first, once again, I forgot my headphones. Because I want to hear, of course, what's going on. So bias is open. I fade in this stable sound of the Neutron. And then I patch the sum of both LFOs to the frequency modulation. And now let me play around with different LFO waveforms and different LFO frequencies. So at first I go and change the frequency at the Volca Modular. Now the frequency is a bit higher. I reduce the frequency of the Werkstatt. And now I do the opposite. I decrease the frequency with the Volca Modular and change its waveform with the upper slider here. Then I increase the frequency of the Werkstatt's LFO. And change it to square wave. A little bit higher the frequency. And changing the waveform of the second LFO in the Volca Modular to up saw and increase the frequency. All right. Now I want to modulate the filter from the Neutron's filter, the cutoff frequency. But I have to increase the basic frequency a bit. So. I change the waveform of the Werkstatt LFO back to triangle and increase the frequency of the Volca Modular's LFO and go to waveform, triangle-like waveform. And changing the frequency here, making it slowlier. And now both frequencies are very slowly. And I fade out the delay completely. The delay was on from the last batch. Okay. Now for a short, small variation of this patch structure. So to make things faster, I have patched it already. The difference is that I go through the buffered multiple, and what I feed in is the oscillator, the LFO from the Volca Modular. So the Volca Modular, the LFO, goes into the buffered in, and from the buffered multiple in, and from there I go with one patch cable into the frequency, cut-off frequency modulation of the Neutron's filter, and with the other one I go into the sum unit, the summing unit, and from the summing unit I go to the resonance. And the second input of the summing unit, what goes to modulate the resonance, comes from the LFO, from the Werkstatt. So the Werkstatt's LFO contributes to the sum, which modulates the resonance. I should perhaps use some light to make it better visible. The sum of both LFOs modulate the resonance, but the share of this modulation, which of the Volca Modular's LFO, depends on this knob of the buffered multiple. The Volca Modular's LFO goes into the multiple, from there into the sum, from there together with the LFO of the Werkstatt. It modulates the resonance, and the frequency of the filter, this filter here, and the frequency of the filter is modulated only by the Volca Modular's LFO, and the amount of modulation I regulate with this knob here. So let's listen to it. And again, I need my headphones. So I put my headphones on. Don't know why I forget them always. Okay, so I fade in. And again, the Arturia keyboard is, is only to ensure a certain minimum frequency. I change the frequency of the Werkstatt, of the Werkstatt's LFO. Oh, there's a bad connection here. So I want to increase the sum. Now I increase the modulation of the cutoff frequency of the filter. I decrease it. I have to change the knobs here. And now play around with the frequencies. Yeah. So now I could use delay, I could feed the sound into the space unit of the Volca Modular, and so on and so on. There are a lot of ways to modify this patch, and even finding the most interesting constellations of these four knobs may take a nice while, because it's pure fun, but I won't bother you with this in this video. I'd rather continue with the next completely different patch. Well, a quite short patch now. I want to use the sequencer of the Volca Modular to sequence the Moog Werkstatt. So what I do is I take the gate out, the node out here of the Volca Modular, and put it into the VCO exponential FMN. Then I need the gate, here, gate in to one of the gates here, and I use the gate which opens the gate with each step. And what a surprise, again, my headphones. So, all right, let me start the sequencer, the Volca Modular sequencer. What we hear is not the Volca Modular, it's here, it's the Werkstatt. Yeah, and I can take different gates, every second step, every third step, every fourth step. But I go back to every step. So I could use the other step outs to, for example, to open the gate of the Neutron and things like that. But I don't want this. It shall be just a short patch here. But what I do is I take the patched LFO output from the Volca Modular to modulate the filter. So I say VCF CV in. Trying different cutoffs. And different filter frequencies. It makes a rhythm now. The relation of the frequency of the Volca Modular sequencer and the rate of the LFO. Different filter different LFO shapes. And I can play around with the amount of pulse width modulation. Different envelopes. Alright, another batch. Well, in this batch I make use of both LFOs here, the LFO, the patched LFO in the Volca Modular and the LFO of the Werkstatt. Whereas the Werkstatt's LFO shall modulate only the Werkstatt itself, the VCO, the pulse width to be exact. The Volca Modular's LFO will have a double function. The first function is modulating the filter cutoff of the Werkstatt, and the second function is modulating the amount of space of the Volca Modular, and the space is needed because I'll patch the carrier's output directly into the space unit. So let me at first patch the LFO here, okay, and then I take, this here, I should have one here, no I don't have, okay, let me use this. Here it is. I have it already. So I put it away. Now I patch the output of the LFO into the split unit, because I need this output twice. So into the input of the split unit, and one output of the split unit I patch to the VCF CV in of the Werkstatt, and the other I patch the other output of the split unit. I patch into the amount modulation of the amount of the space unit, and then of course I have to feed something in directly. I feed the carrier's output here directly into the space unit. Okay, let me at first take my headphones again, it's unbelievable. Okay, and let's listen to what the Volca Modular is delivering. Yeah, okay, all right. I fade it out again. And now let's listen to the Korg, not the Korg, the Moog Werkstatt, of course. Frequency of the patched LFO here. Okay, now the frequency of the pulse width modulation. Basic amounts of space. Yes, here we are. Now the modulation of the space amount works fine. And now I can blend in and out the two synths. So now it's only the Moog Werkstatt here. And now I fade in. resonance here. Okay, some nice drone sounds. With different cutoffs. Different bass amounts of space. And perhaps even a little bit of resonance. There are interesting variations possible. Okay. I've introduced the woggle unit, the random generator of the Volca Modular, into the patch, and the woggle unit modulates the frequency of the Werkstatt's VCO here. This is coming from the woggle. And I've started the sequencer so that the trigger impulses are coming, and I've changed the VCA from permanently on to keyboard mode, and the gate in comes from the gate out of the Volca Modular's sequencer. So the sequencer determines whether the Werkstatt's gate is open or not. Well, let's listen to it. At first, I fade in. At first I fade in the Volca Modular. We have quite high amount of space, so that the sequence, the tones of the notes of the sequence here is right quite in the background. Now I fade in the Werkstatt. Remove the woggle and now insert again without woggle and with woggle. And now I can play around with different adjustments of the space amount, the speed of the frequency of the sequencer, VCS cutoff, perhaps even a little bit of resonance again. Oh, but I don't like resonance here in this patch. Rather quite low cutoff, which is modulated by, don't forget it, by the LFO of the Volca Modular. Okay, but let's go to the last patch for this in this video, which is a quite different patch again. In this last patch for today, I set up, or I patch a little rhythms, and using all three machines, the Werkstatt, the Volca Modular and the Neutron, and all are synchronized by the Volca Modular's sequencer. It is running already. Stop, run. And I take the gate output of the sequencer and patch it into the gate in of the Werkstatt. I'm using the gate output, the trigger impulse at each single step of the sequencer. And then I take another output of this sequencer here, of the Volca Modular's sequencer. I take the every third step output. It's a little bit dark again. I'm aware of the fact that I have to change the lighting here. And this every third output I put into the gate in, I patch into the gate in of the Neutron. Both machines, the Werkstatt and the Neutron, are tuned to bass notes. Let me at first fade in the Werkstatt. All right. I think it's okay. No, it's too much resonance. A little bit less. And then let me fade in the put away the light. Fade in the Neutron. The overdrive is a little bit too much. Yeah, I think that's okay. Yeah, a little bit of dirt in the sound. And at last, the sequence. The Volca Modular. Okay, well, let it be enough patching for this video. I could increase the complexity of of this absolutely non-complex rhythm by using the 8S sequencer here and my clock and but this would be exceed the matter of this, not only this video but also of this series. Okay, but now for some electronics again. Let me talk about the board, the main board of the Werkstatt here as I promised. Some words about the Moog Werkstatt's main board. At least a few things shall be mentioned. I must not use the circuit drawings and give in-depth explanations of the electronics here, not here. Copyright laws and Moog's download conditions won't allow it, but some interesting marginal notes will be allowed, I think. The most obvious thing about the main board is the area called Experimenter Specs, which invites us to do some hardware hacks. And inspecting the whole board a bit closer, we discover lots of islets of lead-outs called TP XYZ, where we can intervene and hack the electronics. The uncommonly rich labeling of the PCB is a great help for everybody who wants to go on hardware adventures with the Moog Werkstatt, an undertaking which cannot be a matter of this video, it can't anymore. I mentioned already that the common and shared electrical ground of all modules on the board is the metal case, which is electrically connected with the PCB using the 5 screws. Well, the VCO. At the heart of the VCO is the TL074 IC, a circuit containing 4 identical operational amplifiers, each equipped with GFET input transistors. The TL074 guarantees low noise and low harmonic distortion, what makes it a simple but great device for audio applications. Some people in the do-it-yourself community report problems and prefer the LM324 IC, but the reported problems, mainly with negative signals or signals of levels near 0 voltage, can be solved by applying some precautions to the power supply of the TL074, something what Moog definitely did here. The whole VCO circuit is quite basic, quite standard, and very, let me say, Moogish. More analog is not possible. We find the same TL074 in the envelope generator and in the LFO, where it acts together with a similar IC, the TL072, which is also a low-noise operational amplifier unit with GFET transistor inputs, so that we get a really high input impedance. A general word about the ICs, the integrated circuits, which Moog uses here may be welcome and possibly even needed. These circuits are purely analog circuits, containing only transistors, diodes, some of them being Zener diodes, resistors and capacitors. Everything nicely analog, therefore, even if those little black bricks may look suspicious to some of you. Let's have a quick look at the VCA now. The core of the basic and solid VCA is the LM3700 amplifier chip, which is found nearly everywhere in the world of analog synths. In Oberheim synths, in search modules, in other Moog synths, and so on. This IC, the LM3700, is an excellent signal to noise has an excellent signal to noise relation. And to be precise, the LM3700 is not a voltage-controlled amplifier on its own. It's a current-controlled amplifier chip, actually. But you will know Kirchhoff's laws and Ohm's law and so on from school, won't you? Well, for those of you who want to dive deeper into the electronics here, there are a couple of videos on YouTube that might help you. And if I notice broad interest, well, some support would eventually motivate me to produce a video of my own about the matter. But this video is definitely long enough now. Thank you, who belong to the averagely 5% of my watchers who follow my videos to the very end. Thank you for watching it. Enjoy your day, but not before subscribing, liking and sharing, and hit the bell after subscribing so that you won't miss out on anything in the future. See you, Rolf.